Okay, so this is section 2. I just want to get you started with this page, and then I will have the answer key to this after you attempt it on Schoology. And then, so you should be watching this video first, then go to the 30, 60, 90 video. Once you're done with that, then go check your answers. So both of these, the 45, 45, 90, is on page 4 of your notes. So you need to have that out. And on page 4, go through this. Then complete page 5. When you're done with those, hopefully you notice a pattern, and I want you to solve for the angles and or sides or on page number 6. Okay. So first of all, there's 2 types of special right triangles. We've talked about different types of triangles, but these are right triangles, and they're special because they have a unique pattern. So the 45, 45, 90, we're going to find this from a square. So if ABCD is a square, we know that all 4 sides are congruent. We also know that all 4 angles are right angles. Okay, so it's important to know. If I were to draw one diagonal from A to C, suddenly I have triangle ABC. And so what we're going to do is we're going to look at the pattern or the relationship of the sides of AB, BC compared to AC. Okay. A couple things here. We know from our quadrilateral unit that when we've got a square, the diagonal will bisect the angles. So what that tells me here is that at angle A, this angle is bisected, so it's cut in half. So these 2 angles are congruent, and half of 90 is 45 degrees. Then at angle C, same thing. I've got a 90-degree angle. It's cut in half. It's being bisected by that diagonal. So I've got 2 congruent angles, and half of 90 is 45 degrees. That's neat. Okay. So I've got this table, and in the end, I want you to come up with a rule that you can think of here, based on patterns of no matter what the side length of AB is, I can figure out, or you could figure out the length of BC and the length of the diagonal AC, which is the hypotenuse. Notice it's across from angle B, that's a right angle. Okay. Let me get rid of some of those because I feel like it's cluttering it just a little bit. Okay. So again, I'm focused on triangle A to C to B. Okay. All right. So what we are going to do is start with the table and work our way down. I'm only going to start you off with this. So the first one here, I have a side length of 1. So hypothetically, if AB was 1, we know AB and BC are congruent, so BC would also be 1. Okay. Yesterday we talked about the Pythagorean theorem. So that is what we're going to use to figure out what the diagonal is. Key thing here for this whole column, I want you to simplify the radicals. So that means I don't want decimals for this column. For AC, I want you to simplify the radicals. Sorry, excuse me. And that will help you notice a pattern here. Okay. So if I take the leg squared, so 1 squared, that's AB, plus BC squared, 1 squared, equals AC, and you can call that whatever you want. Maybe you want to call it C for fun. I don't know. We'll talk about that. Or maybe actually we'll call this H for hypotenuse. Way more exciting. So 1 squared plus 1 squared equals H squared. Well, 1 squared is 1, plus 1 is H squared, which we know that's 2 equals H squared. And as we talked about yesterday, to undo a square, we square root. So I square root both sides and I find out h is the square root of 2. Okay. So now let's say, I'm going to continue this process, that AB is 2. That's right here. Okay. And so if AB is 2, we know that AB and BC, since we started with the square, BC will also be 2. So if I want to solve for h squared, I want to take 2 squared plus 2 squared. So leg squared plus leg squared equals the hypotenuse squared. By doing that, I get 4 plus 4 equals h squared. And that's 8 equals h squared. As great as it is to know what h squared is, I want to know what h is. So square root both sides. I get square root of 8. Hey, we did that problem yesterday. And so to simplify this, remember I'm trying to find factors of 8 where one of them is a perfect square. And I remember, 4 is a perfect square. And 4 times 2 is 8. Okay. And then the square root of 4, we said was 2 yesterday. So when I simplify the square root of 8, I really get 2 square root of 2. Ooh, interesting. Okay. So what I want you to do is continue to find the length of BC, which will, hopefully you notice, always be the same as AB, since those two are the legs and of a square that we started with, those two sides are congruent. Use the Pythagorean theorem to come up with the length of the diagonal. And in the end, I want you to figure out, no matter what the length of AB is, what's the pattern? Okay? So this last row should purely be a pattern. If I started with x, some number, any number, it could be 100, it could be 1,000, it could be 50. It could just be 5. Okay? If this was x, what's the length of BC? If those two, you understand, how does that pattern continue for the diagonal AC? Okay? I want you to stop, well, this video will stop here in a second, and I want you to finish this table, talk to the people around you, figure out what the pattern is, what you think it is, compare it. Then try questions 1 and 2 at the bottom. Okay? Use these patterns to the best you can. I will have the answer key for this page on Schoology. Please check it after you attempt it. Awesome.